stage. That means that if one stage is you are doing, you must complete. For example, BMS is ready, then you can go for, once it is ready, then we can go for the conversion stages. So like that, that one phase after another. And then this design project generally takes many iterations. It's not that once design you do and this is the final. No. You will see integrate, for example, component wise design and the overall system design. For example, we want to design the battery thermal management system. So we have the cell battery cells and combined cells. You have the battery pack. So cell level temperature management and the pack level temperature management, there are a lot of differences. So that is why the design has a different aspect altogether, and it takes many more iterations. And because how you are going to design, for example, you are designing a simple a circuit, and the circuit is very big to accommodate inside your given space of the electric vehicle. So what we do, once we design, we saw that the PCB is printed circuit board is very big, so it cannot insert within that space. So again we will go for one layer not PCB, for two layer PCB. So the size will be reduced to nearly at least 1/3 can be reduced. So this way the design steps has so varieties of challenges as well as varieties of the so that is why the design steps are very particular. And if you see here the design is that you need many varieties of things to understand in this stage. Okay, so that is how the design step are lot of iterations as required. And also you need to do simulation if it is a very complex system, and we can do the simulation as well. And after designing the simulation, then we can build the things. So first one is the design and simulation, and study for the feasibility or feasibility study for that particular system. So these are the main component of the first step. Then second one is to build. Okay, you built this. So how to build it? Means there are two type of building the thing. One is prototype design, and the second one is how to execute this one. So how to build it? One is prototype and actual system building. So what is the prototype? For example, I was working in Indian Railways, and the rating of the motor traction motor is 6000 HP, which is around 4.5 megawatt. Okay, so in our real life or in our experimental lab, we cannot design this one with this specification. Okay, so we cannot design means this will take lot of the hardware complexity to design in the lab. So what we do? We do, for example, 100 kilowatt machine design, and from this 100 kilowatt machine, and we will go on developing another. Then we will test at 100 kilowatt. Then when we build for actual system of 4.6 megawatt, we can go for that. So building is first thing is a prototype design, and the second one, from this prototype design we can understand the entire understanding of this the system, and the system can be implemented in the actual stage. That is the building stage comes. And then testing stage, there are different type of testing. You see, in a EV, generally, if you find, there are so many varieties of testing methods are there, even after the building the EV and before the building EV. And first one is a testing component wise, whether your component, whatever you have designed, whether that is working or that is really it is giving the actual values or actual things, and that is called the testing. You test it. For example, if we have a converter design, you test for open circuit voltage or short circuit test, and also the continuity test, also the forward switching state. So varieties of testing methods we utilize this one, and the testing method gives us more clear picture of how we are going to we are going to implement the complete system. So that is how first one is our this third one is testing. Testing means the testing of component and testing of the overall system, and that is come and this. And once you tested the prototype, if you have tested, you can build the full hardware, or you can second one you can implement for the actual system. That is why the hardware here example is given, hardware and mechanical part like chassis, motor, frame design, where changing is very difficult because you cannot change, so it will be very difficult. So this hardware part, and for example, you are designing EV chassis, first complete the CAD design, then start fabrication. Even if this after CAD design also, it is what material you want, so many varieties of things. For example, once we have developed a CAD mode design, and I gave to one of the manufacturing not one welding shop to build that one, and they built it so heavy that it was impossible to uh, it is impossible for us to drive by the given rating of the motor. So this was very big, and that is how. So it was so heavy that that motor is not able to drive that one. So that is how the first is that we design the EV chassis. First CAD came design. After designing also you saw there are a lot of combinations with material, with design, with the space. And then first you complete the CAD design, then start fabrication. And after fabrication you assemble everything. And after assembling you can test it. And then while testing that one, it will give you so many varieties of things. Then when you start fabrication, and fabrication stage also a lot of challenges, and then the assembly also then test it, because you know that this type of mechanical system design, it is very difficult. Even electrical systems also, when this is a very complicated and complex system, you will find that there is a lot of varieties of the assembly and testing methods, and that can go back easily to change the design once fabrication started. And then the advantage is that clear structure and documentation need to be easy to track the progress, because that you know what is the up to which point you have started to progress. And disadvantage are slow to adapt to change, not flexible if something goes wrong midway. And then second one is agile approach, that is flexible and fast. So work is done in small part, very small. That is called the sprints of 1 to 4 weeks. And team regularly test, review, and improve. For example, you have developed a system, and whatever partial you have developed, you use it, test it, review, and then improve. And it is perfect for software and control system that need frequent updates. That is why that you can frequent update to the required software and control, so that this can be very quickly you can review and test the certain system. And the software based EV systems like battery management system and motor controller firmware and IoT monitoring dashboard. So if you see here, first one is BMS, battery management system. And this battery management system will give you lot of lot of understanding about the thermal aspect of it and the charge balancing. So this BMS softwares are also nowadays these are the you can develop. And then motor controller firmware, whole controller firmware. I remember during our BTech time, MTech time, we used to write the program in C++, like that. And then it completely neglected because to fetch one data you have to write 100 line per program for this. And motor controller firmware and IoT monitoring dashboard. IoT monitoring dashboard, there are the you are building a BMS software 1 to 2 week for charging logic and 3 to 4 week for test and improve, and 5 to 6 add temperature safety features. Each short sprint gives a working version and you improve step by step. So this is the working version and one need to improve step by step. And this method is very flexible. Continue improvement is going on and early feedback. If it is not properly working, then quickly you get feedback. And need strong teamwork and communication. Harder to estimate total time and cost. Then a hybrid approach, best of both worlds. That means combine waterfall for hardware and agile for software. So both these, because in the hardware you can go step by step, and agile you can go parallel by like you do it and test it and get some result and improve it, like that continuously that is going on. And waterfall, it is step by step, so that is good for hardware. And used in modern EV companies and universities R&D labs. So project that what involves both hardware and software. Almost every EV project. Then, for example, you are developing a electric scooter. So, like chassis and battery, you follow waterfall design, uh, basically waterfall that fall, and BMS software and IoT interface or dashboard follow Agile to improve with the testing. So this is the flexibility plus structure and work well for EV R&D, balances speed and safety, and needs coordination between the hardware and software. So if you see here, the waterfall best for hardware and the feature is step by step design. You step by step testing execution is there. And for example, the frame and chassis design. And Agile is the best for software. And key features are small sprint and fast updates, BMS, IoT dashboard, and hybrid mixed the project, combo of both, and full EV project. That means the waterfall plan for first, then built the hardware. Agile built test improve first the software part, and hybrid mix of both for the complete EV system. Oh. So uh, hybrid approach is a requirement, that is design, implementation. In the implementation, we need feedback and design, build, deploy, and testing. Then you verified, then you will get the maintenance. So thank you. We could able to finish this module 2 and we can start